This question, we have the part is shown over here, and there's no slipping between the cord and the surface of the pulley, and the blocks have mass of 3 and 5.7 kilogram respectively, and the pulley has a radius of r, and its moment of inertia is half mr square, and the mass of the pulley is 15.4 kilograms. So what is the acceleration of the 5.7 kilogram mass? So let the acceleration be a this side, and this is a, and this is moving with an angular acceleration of alpha. If this is t1 and this is 5.7 g, which is the weight, this is 3 g and this is t2, and over here we have this t2 and t1 over here as the tensions. So the Newton's law, second law equation on 5.7 kilogram is 5.7 g minus 5 minus t1 is equal to ma. So basically that's f is equal to ma kind of thing. M is 5.7, so that's 5.7a. Let's call it equation 1. The other equation on 3 kilogram is going to be t2 minus 3g is equal to 3a. Let's call it equation 2. And then the net torque on the pulley, since this is the tension and the perpendicular length is r, t1 for t1, so that's t1 r minus t2 r. Why minus t2? Because they are trying to move in the opposite direction, and that's why it's negative. So torque we know is I alpha. Where is I? Moment of inertia. What is moment of inertia? Half mr square times alpha. Okay. So I think r, dividing both sides by r, we have t1 minus t2 as half m r alpha, and t1 minus t2 from here. And we know that acceleration is nothing but alpha r, right? So this can be replaced by a. This can be replaced by a. And what is mass? Mass of the pulley is already given to us as 15.4 times a. So the value of t1 minus t2 is 2 times 7 is 14. 2 times 7 is 14, 7.7a. Let's call it equation 3. So if we add equation 1, 2, and 3, so notice carefully, minus t1 and plus t1 from here, minus t1 and plus t1 is cancelled. T2 and minus t2 is cancelled. So if we add them up, we are left with 5.7 g minus 3g over on the left side, and 5.7a plus 3a plus 7.7a over on the right side. 5.7 minus 3 is of course 2.7, so 2.7 g, and this is coming as 5.7 plus 3 plus 7.7, which is 16.4a. Dividing both sides by 16.4, we finally get our answer of the acceleration as 2.7 g over 16.4 is a. So the value of the acceleration comes out as 1.61 meter per second square. So that's the required answer, and we needed to answer to two significant figures, so I think we'll just remove this one. 1.6 is up to two significant figures. Thank you.